So in topic 2, we looked at version control systems. So if you wanted to upload, say, your code to the server, you would push it to your Git repository, you would SSH into the server, and then you would pull it down from the Git repository. That's the right way to be copying code around. We don't email code around. We don't use other tools generally to copy it between systems. We push it to a repository, and then we pull it down wherever it is we need it. Sometimes, though, you have a simpler use case where maybe you need to upload a PDF to another system, maybe you need to download a text file from a system, and version control would be overkill. So in this topic, we're going to look at a few tools you could use to copy files between systems. So we'll start with the secure copy command, SCP. We'll look at secure FTP, the secure file transfer protocol command. You've already seen curl in assignment 1. We'll take a look at that in a little bit more depth, and then we'll see how this all fits together within the Gall network. So the SCP command, secure copy, is used to copy files between hosts on a network. So when I say the word host, that is simply network terminology for a computer connected to a network. It could be your laptop, it could be your cell phone, it could be your PC, a server. Any device that's connected to a network is known as a host. So, in the same way that we've seen that the CP command can copy files within a host on the same computer, the SCP command is used to copy files between hosts. So the way it does it is, in the background, it will establish an SSH connection, so an encrypted connection, to the remote host, and then it will copy whatever files you ask it to over that encrypted connection. Now, the standard warning applies. It will overwrite any files that already exist. So if I'm uploading, resume.pdf and an older version of my resume already exists on the server, it will happily overwrite it without confirming. So you just need to be a little careful. So let's start by copying a file to another host. So let's suppose that I want to copy a file from my laptop to compute.gall. I'm going to type scp, whatever the file name is, my username on the server, @ and then the host name, so for example, compute.gall.csd.uwo.ca. I'll add a colon, and then optionally I can specify a destination file name or a destination directory. Now, for the destination path, it could be absolute or it could be relative. It can also be a directory name or a file name. So as an example here, I'm using an absolute path /temp. I'm saying I want to upload file.txt from my laptop onto the server into the /temp directory. And so after I do that, it will exist as /temp/file.txt. Alternatively, I could say, okay, I want to upload file.txt as /temp/f.txt. So I'm specifying a destination file name here. And once I'm done, it will be found on the server under that file name. So let's just convince ourselves of this here. On the left side, I'm on my laptop. On the right side, I'm on the server. So we've got file.txt. I will upload it to the server. And we'll upload it to /temp/, just /temp/. So we'll upload it into the /temp directory on the server. Now, normally you would be asked for your username and password. You would type those in and then the upload would proceed. I'm authenticating using public key authentication, so it did not ask me for a password. So we take a look on the server now, and we can see that it has been uploaded as /temp/file.txt. And again, alternatively, I could specify a destination file name. So I could say scp file.txt to jshants4 at compute.gall.csd /temp/f.txt. So the destination file name. And again, if we take a look on the server, we can see now that f.txt exists. Now, alternatively, I could specify a relative path, in which case it will be relative to my home directory. So in the first example, I'm saying upload it into the courses/CS2211 subdirectory within my home directory. So I will find that then file.txt under my home directory /home/jeff courses CS2211, and it will be named file.txt. And again, of course, I could specify a destination file name, in which case it will simply name it that on the server. So again, convincing ourselves of that, we'll SCP it jchance4 at compute.gall.csd.uwo.ca. And this time I'm not going to use /. We're not going to do an absolute path. I'm going to say courses/cs2211, and we'll leave it at that. So that uploads, and now in my home directory on the server, if I go into courses, I go into cs2211, I will see file.txt. Okay, just a few more examples here to drive home the point. So again, if I do not specify an absolute path, it will be relative to my home directory. So in our first example here, if I specify simply a file name, just after the colon, it is going to upload it into my home directory under that file name. So it'll be /home/jeff/f.txt. And of course, if I do not specify any destination path at all, I just have a colon, then it will be uploaded into my home directory under the same file name, file.txt. Now, notice the colon in this. I haven't specified a destination path, but I still have a colon there. You need to remember not to forget the colon. If you forget the colon, it's going to do a local copy. So if we're on our laptop, we want to upload file.txt to the server. So I say SCP it to jchance4 at compute.gall, and I forget the colon. This time, what's going to happen, it's not going to upload it to the server, it's simply going to make a local copy under the file name jchance4 at compute.gall. That's not what I wanted. So you have to remember the colon. If we add the colon, it then copies it to the server, and now it's in my home directory. Now, if I want to copy a directory to a Linux host, it's the same sort of syntax. We just need to add in the -r flag for recursive. So SCP will then recurse into the tree that's rooted at that directory that I'm copying, and it will copy all of the files and subdirectories within it. So let's suppose I want to copy this dir directory to the server. I'll say SCP-R recursive dir to jchance4 at compute.gall.csd.uwo.ca : and we'll just leave it at that. So it will put it into my home directory under a directory named dir. So it copies that all to the server, and I suppose I should have showed you the structure of that directory. And so if we look at the server now, we have a directory called dir. We go into that directory, and you can see that all of the same files and directories exist within there. And then it's the same idea as when we're copying a file. We could either specify an absolute destination or a relative destination. So if I specify /temp, it's going to upload it into the /temp directory. If I specify no leading slash, then it's going to be relative to my home directory. Now, one thing to watch out for is if the destination directory already exists on my system, then it's just going to happily start overwriting files. So to see what I mean here, we have this directory dir on the server, and let's just edit F1, and we'll just say this is F1 from the server, and maybe we'll just do this is F2 from the server, and we'll put that into B/F2. And then on my laptop, so again, in my home directory, I've got this dir subdirectory. On my laptop, I'm going to say SCP-R dir to the server and upload it into my home directory. So it's not going to do any kind of confirmation, but if we now take a look at the contents of our files, you can see that it no longer says this is F1 from the server. It has overwritten it from my laptop. Oops. So just be careful with that. Now, you may be looking at my slides, and you may notice that when I specify a destination directory, I will typically add a trailing slash on the end. That's not strictly required, but it's good practice. It's sort of a safe thing to do. To see why, what we can do on the server, let's suppose that I have a file named dir2. Okay, we've got a file now named dir2. And let's suppose that on my laptop, I am uploading file.txt, and I want to upload it into a directory called dir2 on the server. So if I do that, it's not going to upload it into the directory dir2 because dir2 is not a directory. It's simply going to overwrite that file, and that's not what I intended. If instead I were to say scp file.txt to the server, and again, I want to upload it to dir2, but I want to put it into the dir2 directory, I will put a trailing slash on the end. And if that directory does not exist, if it's a file, then it will simply tell me, hey, that's not a directory. It's not going to overwrite the file. It'll just refuse to upload it. So it's just sort of a safe thing to do. If you're uploading into a directory, then I recommend putting that trailing slash on the end. So we've seen how to copy files from our laptop to a remote host. If we want to copy a file from the remote host down to our laptop, we just reverse the arguments. So it's going to be scp, whatever your username is on the server, at the server name, compute.gall, colon, whatever file you want to download, and then where you want to download it to. So a couple of examples here. If there was a file.txt within /temp on the server and I wanted to download it to the current directory, you'll remember that we said that dot is a special reference to the current directory. So it will copy file.txt into the current directory on my computer. Another example, I could say, okay, here's a relative path. So in my home directory, go into courses, CS2211, get the file readme.md, and I want you to copy it to the parent directory on my computer as the file readme.txt. So just an example to convince ourselves of this, we're on the server. Let's make a file called remote.txt. We've got it there. We want to copy it down to the current directory from our home directory. So we'll say compute.gall csdew.ca colon remote.txt, and I want to download it to the current directory. So I say dot. And now it's been copied down. Same thing with copying a directory from a Linux host to your laptop or to your system. You would simply add the -r flag. Same idea here. It will do a recursive copy down to your system. Okay, so if I wanted to copy /temp/dir1 to my current directory, again, I'm using the -r flag and I'm using dot as my destination directory, and that will then copy it into the current directory as the directory named dir1. So that is the scp command that allows us to non-interactively copy files between hosts on a network. Another option is the SFTP command, Secure File Transfer Protocol. It's similar to an older protocol called FTP, File Transfer Protocol, but it operates now over a secure SSH connection. So again, when you establish an SFTP connection to a server, it will behind the scenes establish an SSH connection to the server, and then any communication that takes place, any files that get transferred, will be done over that encrypted connection. So the difference with SFTP is that it provides an interactive session. SCP was a non-interactive copy. SFTP allows us to connect to the server. We can CD around the file system. We can make directories, delete directories, rename files. We can upload and download multiple files. So it very much provides an interactive session, much like when you SSH into a server and you execute commands at the shell. It also supports a whole number of features that are not offered by SCP. So again, you can list directory contents, delete files, rename files. You can even resume transfers. So if you were uploading a file and maybe your Wi-Fi drops, you can later SFTP into the server and resume that file transfer rather than having to copy the file from scratch all over again. So if I want to establish an SFTP connection to a server, I will type SFTP, my username at whatever the server name is. So let's type in on the laptop SFTP, my username at the server name, compute.gall, no colon this time, this isn't SCP. And now I'm connected. And once again, you would be asked for your username and password. Now, once you're connected, there's a whole host of commands that you can possibly execute. One of the first things you might want to do is simply type help. So if you type help, that gives you a list of all sorts of commands that are available to you. So you can have a look through that. But you can see some familiar commands here. So we've got things like ls. So I can list the contents of the remote directory. So they list the contents of the current directory on the server. We've got rename. So instead of mv, we've got rename. Rename one file name to another file name. We have the familiar rm to delete a remote file, or rmdir to delete a remote directory. pwd to list the current working directory on the server. And of course, we have cd and make directory to move around and create directories. Now, in addition to these remote commands, we also have these local commands. So ls is going to list the remote directory, while lls is going to list the local directory. So in other words, the directory on my computer. Okay, so let's just try a few of these commands here. So if I type pwd, it's telling me that, okay, on the server, you're currently in your home directory. I could say something like ls, and that's going to list the contents of my directory on the server. So let's go into, I don't know, dir. And now if I say pwd, I'm in that directory on the server. If I want to know what directory am I in locally on my laptop, I can say lpwd, local print working directory. And that tells me, okay, you're in that directory on your laptop. I could say lls to show the contents of my current directory locally. And that shows me the contents of my directory on my laptop. Now, to upload a file to the server, I can use the put command. If I'm uploading a file, I'll just say put and then the file name. If I'm uploading a directory, it's going to be put-R and then the directory name, and that's going to do a recursive upload. So let's give this a shot. So let's change back to my home directory on the server, and maybe we'll make a directory SFTP. We'll change into that, pwd. Okay, I'm now in the SFTP directory on the server. And let's take a look at the local contents of our current local directory. And maybe we want to upload file.txt to that SFTP directory. So I'll simply type put file.txt. It uploads it to the server. And then if we go on the server and we take a look, we have our SFTP directory there. If I change into it, you can see that file.txt has been uploaded. Alternatively, if I wanted to upload a directory, so let's suppose that I want to upload this dir directory, then I will say put -R dir, and that will upload recursively the entire contents of that into the current working directory on the server. And you can see now, there it is. Okay, same sort of thing with the get command. So if I want to download files or directories, I will use get. So let's just create, I don't know, SFTP remote.txt, and we'll make another directory. Well, let's just we'll rename dir to remote dir. Okay, so now that's what our directory looks like on the server. And if I wanted to pull down SFTP remote.txt, I'll simply type get SFTP remote.txt. And now it's fetched it from the server. If I look at the contents of my local directory, you can see I now have that file. Similarly, if I wanted to pull down that remote directory, I would say get -R remote dir, and once again, it does a recursive copy. And so again, if I look at the contents of my local directory, now I've got that remote dir. Okay, so that's the SFTP command. Again, it provides sort of an interactive session over which you issue commands and then certain actions take place over the course of that connection over time. So I SFTP into the server, I issue a command like get file1.txt, the server then sends it to me. But the connection doesn't end. It allows me then to issue another command like put resume.pdf, and then my client uploads that file. And then eventually when it's time to disconnect, I will simply type exit and the connection will be terminated. Okay, so I simply type exit and then the session is over. Okay, moving on to the curl command. So you've already seen the curl command in assignment 1. It's used to transfer a URL, so some sort of remote web address. So we can use it to fetch web pages and files from the web. You can use it even to upload data to a web server. So you could actually fill out a form or upload a file to a server using curl. So it's an excellent tool that developers often use if they're developing, say, an API that is web-based. They will use it for testing out the API that they have developed. Now, it's important to note that curl is a command that you can run at the command line. It's also a library that you can embed into your program. So it's available for a wide variety of languages: C, Java, Python, PHP. All kinds of different languages have a port of the curl library. So if you wanted a program to download a file from the web, you can use libcurl, the curl library. So the simplest use of curl is simply to type curl and then give it the URL that you are looking to download. If I wanted to download, say, file1.txt from www.example.com, then I would type curl and give it that URL, and it will fetch it and it will display it by default to the screen. It's not actually going to save it to a file. Now, if I wanted it to save it to a file, then I could use -O. And what that will do is whatever that file is named on the server, it will save it into the same name locally. So file1.txt on the server is going to now be downloaded as file1.txt on my system. On the other hand, if I want to specify a destination file name, I can use the -o option, and then I specify a file name. So here I'm downloading file1.txt from the server, and I'm saving it as download.txt on my local system. Just to show you a few examples of that, if we say curl https www.csd.uw.ca/file.txt, again, by default, that does not download it to a file. It simply fetches that file and displays it, or fetches the web page and displays it. If I say curl-o, so let's add in -o, that will download it. And now if we look at file.txt, that's the file that it has downloaded. Alternatively, we can use o and specify the output file name. So file from the web.txt. And there it is. Now, it's not super important that you understand this. However, sometimes what's going to happen is you will be redirected by a web server. So if I try to access the computer science department's webpage and I don't use HTTPS, I'm using HTTP, you can see that the response it gives me, it's called a 301 redirect. So it's trying to redirect me to this location here. So if I want to tell curl to follow redirects, I can use curl-L. So I'll say curl-L. I'll give it I'll try the same URL. And this time it's going to actually follow that redirect and fetch the web page from that URL. Now, if you want to see what's happening there in the server response, we could say curl-I csd.uw.ca, and you can see when I tried to access it without HTTPS, it gave me this 301 redirect, and it told me I want you to go to that location, go there instead. And then if I actually go there, then it gives me a 200 OK. In other words, it's going to now send me that web page. So curl-I can just be used to see what's going on from the server. It shows you what are called the HTTP headers that the server returns. You don't need to understand anything about this right now. I just mention it for the sake of interest. Now, if you're feeling like you want to waste a little bit of time, I've put a few websites here that you might want to try curling. They have actually created these websites to be curlable. So, for example, we've got cheat.sh. So if we curl cheat.sh, you can see that it gives us a nice little colored textual interface here. And it tells us that, okay, if you wanted a cheat sheet for the ls command, you could run curl cheat.sh/ls. If you wanted it for BTRFS, you can get a cheat sheet on that. So let's try it. Let's say curl cheat.sh/ls. And you can see that it gives me a nice little cheat sheet that tells me how to use the ls command. So if you're allergic to man pages, you can take a look at these cheat sheets. We could do curl cheat.sh for the makedir command, for example. Pretty much any Linux command, there should be a cheat sheet there. And again, you can see that now we have a nice little cheat sheet for makedir. It's kind of neat. If you're finding that you're in the terminal and you just can't bring yourself to switch to your web browser, you need a weather report right now, you can use wttr.in. So I'll say curl wttr.in, and let's see what happens. And what does that give us? Weather report for not found. So it's not clear if it knows where I am, but what I could say is curl weather in London_Canada. And there we go. Now I've got the weather report for London, Ontario, Canada. Not sure how super useful that is, but hey, if you just can't bring yourself to leave your terminal to check the weather or, just go outside, there you go. You've got WTTR.in. Animated GIFs. Apparently you can curl animated GIFs as well. So curl gif.xyzzy.run. And what does this tell us? Okay, so we can run curl this URL / whatever search terms we have separated by an underscore, and then it's apparently going to show us a terminal-based version of an animated GIF. So let's try our math lady. Curl gif.xyzzy.run / math lady. And there we go. We've got our math lady doing some geometric calculations. And just a few others here. Cryptocurrency exchange rates. This one is useful. ICANN has IP. Sometimes you need to know your remote IP address, not your local private IP address. You need to know what your public facing IP address is. If you curl ICANNHasIP.com, it will show you what your remote IP address is, and that can be useful sometimes. And then finally, this is a neat little one. If you want to upload a file, you can say, let's say I had a file test in my current directory. So I could say, okay, let's say this is my file. We'll call it test. I could say curl-F file equals @test. That's just curl's way of referencing a file. We have to put an @ in front of it. And then I can upload it to 0x0.st. And now that gives me a URL that I can now share with somebody. So if I go into my browser now and I go to that URL, you can see that my file has been uploaded. I think it stays there for a month or two and then they automatically delete it, but kind of a useful way to quickly share something with someone. Okay, so that's the curl command. Just a quick note here on our Gall environment here within the Department of Computer Science. So when you SSH into compute.gall, or when you log into an MC244 system, your home directory is not actually stored on either of those systems. It's actually stored on a file server in the network, and then it gets mounted onto whatever system you've logged into. So if I SSH into compute.gall, my home directory is automatically mounted onto compute.gall. If I log into MC244, same idea, it gets mounted onto that lab system. What that means is that you do not need to SCP files around or SFTP files around between systems on Gall. So if you create a file in your home directory on MC244, on one of the lab systems, it's already in your home directory. So when you SSH into compute.gall, it will be there. You do not need to then, SCP the file up to compute.gall. It's already in your home directory because your home directory just gets mounted down onto the server from a separate file server. Okay, so no need to use the commands that we've learned here if you're simply looking to copy files and directories between, say, compute.gall and the MC244 systems. Now, one thing to note is that we do back up all of your home directories every night. So if you need to restore a file that you've accidentally deleted or overwritten, you can open a ticket with Science Technology Services at helpdesk.sci.uwo.ca and just give them the path to the file or directory that you need restored, and they can help you out with that. Now, a caveat is that they cannot restore files that were created today. Your home directory is backed up every night, I think around 1 a.m., which means that if you created a file, say an hour ago, and then you accidentally deleted it, that file hasn't been backed up yet. So as long as your file or directory that you're looking to restore was created more than 24 hours ago, you can open a ticket. Otherwise, I'm afraid you're out of luck. So that's it for this topic. We've seen the SCP command, secure copy, a non-interactive way to copy files and directories between hosts. We saw that you have to pass the -R option, recursive, when you're copying directories. And of course, do not forget the colon after the host name. Otherwise, it will just act as the CP command and do a local copy. And of course, if you do not provide an absolute path, then the path that you specify after the colon is relative to your home directory. We looked at the SFTP command, Secure File Transfer Protocol. That's an interactive file transfer protocol that allows familiar commands that you've seen before, pwd, ls, cd, and so on. You can cd around the file system. You can upload files, download files. You can even resume file transfers that may have been interrupted. We saw the curl command, of course, to fetch and display pages and files from the web. We saw how we can output those files to a local file using either -O or the -O option. And then finally, we saw that within the Gall network, you do not need to use these file transfer commands. Again, if you're just trying to copy between MC244 and compute.gall, your home directory gets mounted on those systems. So make a change in your home directory and that change will be reflected on all Gall systems immediately. Finally, as usual, I have a topic 3 cheat sheet here that just gives you some of the more common operations for SCP, SFTP, and curl. So feel free to use that. And that's it for this topic.